Knock knock, who is it? It's me, Sir Benathang, standing in front of you all in good health and in sound mind. And to whom do I give credit to? I give all my credit and thanksgiving to Almighty Father God, who is in heaven and who has been ever kind and gracious to me and has brought me this far. So once again, my dear students, I welcome you to this channel, Classroom, where we learn together. So the journey has been very, very amazing. Remember, it is the journey, okay, which we remember. It is the journey. The most memorable part about the climb is the journey. Alright? Because once you reach the top, that's it. Okay, it's over. Okay, now you'll have to proceed to further heights again. But what you will remember is the memories that you have made while you were climbing. So the climb is the most important part. Remember that, okay? At one point you will reach the top, but the most memorable part where you had fun, laughter, and all the emotions, it was in the climb. So remember, it's the climb. Okay, there's a song by Miley Cyrus, about the name of the song is, I think, The Climb. It's a good song also. So it's the climb. Okay, the climb is the most important part, and the climb is the most crucial part, at the same time the most fun part in our life. So enjoy the climb. Okay, don't rush. Okay, eventually you'll reach your destination, eventually you will reach your goal, but enjoy today, because today is a present. It's not said by somebody, okay, I don't remember, but it was said by someone that today is a present. Okay, so live the present, and to make sure that, okay, you enjoy your tomorrow, do your part today, so that tomorrow also you get to enjoy and live a comfortable and a happy, peaceful life. Okay, so once again, okay, I welcome you all. All right, so my alarm is ringing. See, that's my alarm. Okay, so our topic today is electric power. So let's define electric power. As per your textbook definition, electric power is, it is the rate at which electrical energy is transferred in an electric circuit. I repeat, it is the rate, or it is the speed at which electrical energy is transferred in an electric circuit. Okay, so let's write down the definition. So grab a notebook, pen, pencil, and copy down. Okay, so electric power. Electric power. It is the rate at which electrical energy is transferred in an electrical circuit. So this is the definition of electric power. It is the speed, or it is the rate at which electrical energy is transferred in an electrical circuit. Okay, so you have to know the SI unit of electric power also. So the SI unit of electric power is WAT, watt. Okay, now moving ahead, we'll do a derivation for the formula, okay, of electric power. Now before we proceed to the formula, let us quickly go do a revision of what we have learned in class 9. So in class 9 we have learned some formulas of power. What are those? So in class 9 you have learned that power is equal to work done divided by time taken, means power is equal to W by T. In class 9 you have also learned another formula which is for power, which goes like energy divided by time taken, which can be written as E divided by T. So this is what you have learned in class 9. Now to start our derivation, we will be using this first formula. So we have power is equal to W by T. Now what we will do is, we will replace the value of W with a formula of W. So we have a formula for W which goes like this. W by Q. So cross multiplication, you will get W is equal to VQ. So instead of writing W, we will replace W with VQ. So P is equal to VQ by T. Now pay attention to this part. Okay, Q by T. Q by T, it is the formula. Okay, it is the formula of something. Which formula is it? This is the formula of I. Okay, so but I, which is current, is equal to Q by T. So Q by T can be replaced with I. So P is equal to V I. Instead of writing Q by T, I'll write I because I is Q by T. So this is the formula for power. This is called the general formula. Okay, very important for numericals. Now from this general formula, we will derive two more formulas. Okay, so let's write down this here. So P is equal to VI. From here we will get two more formulas. Okay, so using Ohm's law, so we'll be using Ohm's law. Using Ohm's law, so Ohm's law is V is equal to IR, isn't it? So here we'll use this first formula, which is V is equal to IR. So instead of writing V, I will replace V with IR. So it will look like V. I will not write V anymore. Instead of V, I'll write IR. So I'll write IR, and this R will remain as it is, isn't it? Okay. Oh, sorry, I is here, no? So I is here. Why am I looking here? I should be looking here. So P is equal to I square R. This is the other formula of power. The first formula being this, and this is the other formula of power. All right. Now we will derive another formula. Okay, using Ohm's law. Now we have just replaced V. Now we'll replace I. So let's make a formula for I from here. So keep I where it is. V will be where he was. R will come below V. So instead of I, we'll write V by R. So P is equal to V into, I will not write I will write V by R. V by R. So P is equal to V square by R. This is the other formula of power. So altogether, how many formulas are there? 3. General formula, another formula, another formula. Now let me tell you where you will use this formula and where you will use this formula. We will be using this formula in those questions where the combination is in series. So use in series. Okay, use in those questions where the combination is given in series, and this will be used in those questions or numericals where the combination is in parallel. So use in parallel. So this is it. Okay, my dear students, this is the first part of the discussion about electric power. Now we have a small topic, okay, on the topic commercial unit of energy. So let's discuss that. So let me erase this quickly and let's go to the topic. Like I said, this topic is going to be a small topic only, but since it has got important formulas, I want to specify on its importance. So the next topic is commercial unit of energy. Commercial unit of energy. So who can tell me the meaning of the word commercial? Commercial. What is the meaning of the word commercial? Commercial means, yes, trade. So in here, whose trading is going on? The trading of energy is going on. So does that mean energy can be bought and sold? The answer is yes, energy can be bought and sold. But then who is buying it and who is selling it? See, electricity comes to our home and we pay for it. So who is buying it? You and me. Okay, we are buying it. But then who is selling it? Those who produce it and distribute it, they are selling it. So who are they? They are the government or big private companies. When we speak in terms of our own state, Nagaland, then here, okay, the state government provides us with electricity, and in return we pay money to them. But in those states where the private companies are distributing it, the consumers have to pay money to the private companies, and in return the companies will send current to their homes. So here trading is going on. Trading of energy is going on. Okay, so the trading of energy takes place in commercial unit of energy, which is called kilowatt hour. Okay, so the commercial unit of energy is kilowatt hour. Here I need you to pay attention to these two words, hour and watt. So hour is a unit of time and watt is a unit of power. So it's power into time. Power into time is a formula of energy. So this becomes this becomes the formula for calculating energy. So this is the formula for calculating energy. Okay, so in short, kilowatt hour can be written as small letter K, capital W and small letter H. Remember this, okay? And very important term and very important thing for you to remember is 1 kilowatt hour is equal to 1 unit. Very, very important. And also equally important is 1 kilowatt hour gives us 3.6 into 10 to the power 6 joules. 3.6 into 10 to the power 6 joules. This is very important for your MCQ. Important for MCQ. So this is it, my dear students. Okay, the lesson has come to an end. So before I go away, before we end this video, I have a question for you, which I want you to give the answer in the comment box. So the question for today is, how many watts make 1 kilowatt? So you kindly give the answer in the comment box. So that's it. Like I said, this was a short topic, okay, but then I want to emphasize on this. That's why I made this video. And so with this, the videos on the topics have come to an end. But like I said, the next videos which will follow will be on the numericals. So do not miss those, because okay, I know you struggle a lot on numericals. So make sure to watch the numericals and learn. Okay, I'll be doing solving and updating all the numericals in the exercises. So make sure to tune in and learn. So once again, thank you all for tuning in, my dear students, and I'll see you again in the next video.